Hello and welcome to another exam paper walkthrough. I'm going to continue with my AQA half paper series today. We're looking at a past paper from AQA and we're looking at the June 18 paper 2F. A couple of weeks ago I recorded the even question version. Today I'm going to be recording the odd questions. So that'll make a complete paper 2F if you put the two videos together. Attached to the description of this video, you will find a link to my Google Drive where you can download a copy of this paper. I would strongly recommend you've either done the paper beforehand or you do it alongside the video just to get the most out of it. I would also recommend having some music on in the background. While I'm recording these videos, I tend to have an ear pod in with some music going on in the background just to make it more enjoyable. If you find it useful, please do subscribe if you like. Okay, before I get on with the video, what I do want to briefly discuss is the breakdown of this paper. So this is kind of a Q&A, I've forgotten their exact wording of this, but this is produced by your exam board, produced by AQA. What I've done is I've just pulled together the odd questions. So this paper has a maximum mark of 44. And the national mean mark for this test, when it was sat kind of by looking at the performance of the data, the average mark for this was 18.25%. So the average grade boundaries for this based on the students that sat it. So on average, all the students that in 2018 that scored a grade 5, their average mark for this paper was 33. The grade boundary for this paper was 33. For a 4, we were looking at 26. For a 3, we were looking at 19, and so on, which is quite useful in terms of giving yourself some idea of what grade you would get on the paper. What I've included on this one but didn't on the last video, because I think this is quite useful, is actually question facility by grade. So in effect, what that really means is that out of all the students that sat this paper who got a grade 5, the average score, this is the average percentage for each of the questions. So that kind of shows you that on this paper, question 25B was the least well done at the grade 5. So you can kind of get a kind of a fair kind of working out of which questions were the most difficult. And quite surprisingly, one of the most poorly done questions was question 7C. That's just quite useful. And I'll bring that back up after we've done the paper, but I will start the paper now. Okay, so here's a copy of the paper. QR code on the front takes you to this video, which you may or may not already know. Right, so question 1. Circle the expression that can be written as 2y. Well, 2y really means y plus y. So we're going for that option there. Right, question 3. What is 625 as a power of 5? So the most straightforward way to do this is, if you don't know originally, you can test all these out because this is a calculator paper. So if we just do, let's take the first one for a specific reason, 125. So straight away, first option. Okay, work out the value of 3 to the power 6 minus the square root of 841. So I would just go straight for my calculator for this. So 3 to the power 6 minus the square root of 841. So 700. I'm writing it in the wrong place straight away. 700. Okay, question 7. E is 3 more than D. F is 5 more than D. Write an expression for E in terms of D. So for this, we are looking at, so write an expression for E in terms of D. So, that's this statement here. 3 more than d, so d plus 3. Or d plus 3, or 3 plus d, either way around. An expression for f in terms of d. So an expression, obviously we don't need an equal sign for an expression. F 5 less than d, so that's going to be d minus 5. Okay, and part C, work out E minus F. Well, E minus F, we've just written down what E is and we've just written down what F is. So E minus F is going to be D plus 3 minus D minus 5. So that would work, but it says simplify your answer. Well, D minus D, they in effect cancel each other out. So we're left with 3 minus negative 5, which becomes 3 plus 5, which would give us 8. Okay, I'm just going to pause there. I've got a feeling I've made a mistake. So here, when I typed in 5 to the power 3 and said that that was right, because I got my screen a bit smaller, I was actually supposed to be comparing it to 625, and that's 125, so I'd got that one wrong. So let's try to the power 4. So it's 625, so it should have been that one. So I'd circled the wrong one initially, misread 1 and 6. Okay, back to question 9. In this equation, use 1 foot equals 12 inches, 1 inch equals 25 centimeters. Change 5 feet 8 inches into centimeters. So I could do this in separate stages. I'm going to do it as 1 though. So I'm going to say that 5, I'm going to say I want to in effect convert it all into inches first of all. So I'm going to do 5 times by 12 plus 8, and that would convert it all into inches. And then once I've done that, I want to times that by the conversion to do it into centimeters. So open bracket 5 times 12 plus 8, close bracket, times by 2.5, and that should give me my answer, 170. If you've broken it down into a number of steps, that's absolutely fine. There's nothing wrong with that. Arguably, it's clearer where you'd pick up your 3 marks. It's going to be 1 mark for this part, 1 mark for then times it by 25, 1 mark for your correct answer. Okay, question 11. Nick has a 6-digit code. He remembers it as 2-digit numbers. The first number is between 10 and 20, so that means that there's only between, so that means that there are only 9 possibilities. The second number is 3 times the first. The third number is 5 times the first. All 6 digits are different. Okay, that's a key bit of information. All 6 digits are different. So I'm going to kind of do it like this. He could have had, well, he can't have, the first one can't start with a 1 and a 1, because that would be, so it's got to either be a 1 and a 2, 1 and a 3, a 1 and a 4, 1 and a 5, 1 and a 6, 1 and a 7, 1 and an 8, or a 1 and a 9. And then we can start thinking about possibilities. So 3 times as much would give me 36, and then 5 times would give me 12 times by 5 would give me 60, so that can't work. 13 times by 3 times by 3 would give me 39, so that can't work. Same digit. 14 times 3, 42, won't work. Can't automatically know this because if I times anything by, I'm going to get a 0 each time here, but we'll show that anyway. 15 times by 3 would give us 45, so 5 and a 5, can't be that one. 16 times by 3 would give me 48, so that one would work, and then instead times it by 5 gives me 80, and we've got a repetition of the digit, so it can't be that one. 17 times by 3 gives me 51. Digit 1 repeating, so it can't be that one. 18 times by 3, 54. And then 54 times... sorry, where was I? 18 times by 5 would give me 90. So that's definitely a possibility. I'm just going to show that the last one doesn't work, or see whether that's another possible option. 57, and instead times by 5, 95. We've got a repetition of the 9 and the 5. So the only possible option is 1, 8, 5, 4, 9, 0. Right, question 13. Here is the formula for the amount of water needed to cook rice. W is the number of cups of water needed. R is the number of cups of rice to be cooked. How many cups of water are needed for 7 cups of rice? So we're substituting. So let's just make that a bit clearer. R then is going to be equal to 7. So I want to do. So W is going to be equal to 1.5 times by 7 plus 0.5. Again, because it's calculator paper, I'll just rely on the calculator for that. So 11. Right, for part B, how many cups of rice can be cooked with 20 cups of water? So W is going to be equal to 20. So 20 is going to be equal to 1.5 times by R plus 0.5. So I'm going to minus 0.5 from both sides. So 19.5 will be equal to 1.5 times by the number of rice, and then divide by 1.5. So R is going to be equal to 19.5 divided by 1.5 gives me 13. So 13. Right, question 15. The graph of y is equal to 4 minus x for the values minus 2 to 5 is shown in the grid. So this is going to be y is equal to 4 minus x. Let me just check. So general equation of a line, y is equal to mx plus c. So c would be the intercept, so we should cross at 4. It does. And it's got a negative gradient, negative 1. So for every 2 across, it would go down 2. Sorry, for every 2 down, it would go across 2. So that works fine. On the graph, on the grid, draw the graph of y is equal to 2x minus 5. So if y is equal to 2x minus 5, I'm going to say that the gradient is going to be equal to 2. And the intercept on the y-axis will be minus 5. So minus 5 would be that point there. And then for every 2 across, or for every 1 across, it will go up 2. Right. Then I want to join it with as smooth a line as I can. So that's going to be my line. Right. Just checking it covers the range. Minus 2 to 5 it does. Okay, use your graph to solve. So we've got the solution for y is equal to 2x minus 5. So we've got this part here, and we've got this part here. And then being equal. So after the intersect, and the x value when they cross is 3. Question 17. Here is a map of an island and cities A, B, and C. Straight line represent roads. So 1 centimeter represents 200 kilometers. A is due west of B. So A is due west of B. Write down the bearing. So I'm going to add on a north line. and I want the bearing. So that would be that bearing there. Technically that's 90 degrees. So the bearing would be 270. Right. And part B, Umar drives from A to B on the route shown. Kaz drives from B to C on the route shown. Use the map to work out how much further Umar drives than Kaz. You must show you're working A to B. Okay, right. So I need a ruler for this. Okay, obviously my scale is going to be slightly different to yours, but provided you've done it right, it won't really affect anything. So on my ruler, I'm going to call this 0. So 1, 2, 3, 4, 5 centimeters. So that length there is 5 centimeters. And then this length here is, let me try and twist my ruler around right. Still not quite right. There we go. So we've got 1, 2.1. So that length there is 2.1. And then that length there is 1.6. So A to B is 5, and then B to C is equal to 2.1 plus 1.6. So we're looking at 3.7 there. So I'm going to switch back to my sheet now, hopefully. So I want to do 5, take away, I think I said 3.6. Let's just double check. 3.7. So that's going to be 1.3 centimeters difference. And then I've got a scale of 200 kilometers represents 1 centimeter. So I need to times this by 1.3 times by 200. So for me, that's going to be 1.3 times by 200. So 260 kilometers. Right. For you at home doing this, you will probably get a slightly different answer to me, and there's a couple of reasons for that. Firstly, you're going to have a different scale to me. I know the students that I sent home had a scale of, they were printed as A5 booklets, so there'll be a slightly different scale on there. But the method will hold true for either. And also, even if you had the A4, I've got a different scale on my ruler than you probably have because I'm doing it digitally. I can bring up the, I'll have a quick look at the mark scheme. Right, so the mark scheme says that the measurements, if you're doing it in A4, the measurement should have been between 6.3 to 6.7 for AB. For B to C, for the first measurement, anything between 2.5 up to 2.9 was fine. And for the second part, anything between 1.8 and 2.2 was fine. But again, if you're one of my students and you've been doing this on an A4, A5, your answer will be slightly different. And if you're doing it on the A4 version, your answer, let's have a look, your answer should be It just says the correct answer taken from your measurements. Okay, right. Question 19, multiply out, circle the correct answer. So if we multiply this out, that would give us x squared minus 4x. So that would be this option here. Right. Question 21. A circle has a radius of 4.2 centimeters. Work out the length of the circumference. So we've got two formulas for the length of the circumference. Circumference is equal to pi d, or circumference is equal to 2 pi r. The version we want is the one involving the radius, so I'm going to say that the circumference will be equal to 2 times pi times by 4.2, which gives me 2 times by shift pi times by 4.2. So I'll write it down exact, 42 over 5 pi, but as a decimal that would be 26.3893 ... show no rounding, and then to round it to one decimal place, 26.4. Okay, question 21, draw a sector. So I always remember this as sectors of pie chart, so that would be a fairly straightforward sector. Technically speaking, you could have got away with that because that's 2 sectors of semicircle. But that would be the one I would go for. Right, question 23. Match these to their description. So we've got a series of numbers and then types of sequences. So I'm going to look on this side first of all, because I think that the cube numbers will be easiest to spot. Square numbers will be the easiest to spot. 1 squared is 1, 2 squared is 4, 3 squared is 9. So that's that one. Cube numbers, again, are quite easy. We're timesing them by themselves 3 times. So that's going to be our cube numbers. Arithmetic progression means a sequence that has a constant difference between each of the numbers, which is this sequence here. Geometric means that there's a multiplication pattern between them. So here we've got doubling, so times in by 2 each time. So that's my geometric progression, which leaves, hopefully this would be my triangle numbers. If you're not sure what triangle numbers are, they're numbers that form a triangle. So first row would be 1, second row would be a total of 3, the third row would be 5, the next row would be 4 dots added, so 9. Hopefully that's the missing one. Well, yeah. No, I've miswritten. So I've drawn them right, but written them wrong. 1, 3, plus 3 is 6, plus 4 is 10. There we go. Okay, question 25. On 3 days, Ali throws a dart at a target. Here are his results. Work out 2 different estimates for the probability of Ali hitting the target. Right, so I'm going to go for the most accurate first of all, which would be this one here. So number of hits divided by number of throws. So I'm going to go 54 over 90. And then I think that will cancel down by 9. Which would give me 3 over 5. So it's actually cancelled down by 18. So I'm going to go, help if I wrote before I spoke, 3 over 5. And then you can use any one of these for your others. I'm going to use, change pen colour just to show, I'm going to use the next most accurate, 17 over 40, which won't simplify. The reason it won't simplify is 17 is a prime number. Which of your answers is the better estimate for the probability of Ali hitting the target? So I'm going to go for 3 over 5. And the reason being it's taken from a larger data set. So the larger the data set, the more accurate the results will be. We're using will be more accurate because the trial has been done or because he's thrown it more times. Reason he has completed the, what would we call it, a test. He has completed the trial more times. Okay, question 27. Right, this is actually crossover on the higher tier. Volume of a sphere is 4/3 pi r cubed, where r is the radius. A container is a hemisphere of radius 30 centimeters. Sand fills the container at a rate of 4,000 centimeters cubed per meter. Does it take less than a quarter of an hour to fill the container? You must show your working. Okay, so I'm going to work out the total volume of the hemisphere. So I'm going to do 4/3 times by pi times by 30 cubed times by a half, because we only want half of the total volume. So that's going to be equal to 4/3 times by shift pi times by 30 squared cubed times by 0.5. So we've got 118,000 pi, which as a decimal would be 56,548.6 ... unit centimeters cubed. Right, in a quarter of an hour, that's 15 minutes. So the tap would fill, or the sand would fill, times by 15. So the sand would fill 4,000 times by 15. So the sand would fill 60,000 centimeters cubed. So would he have filled the hemisphere? Yes. You must show your working. I'm going to go here. Yes. As 56,548.6 ... is less than 60,000. So yes. And that brings us to the end of the paper. Okay, so again, grade boundaries for that paper are on there. I'm planning to chapter index this video with the topics for your additional revision. Hope you found that useful. Again, you might be able to understand now why the two hardest questions there were the best estimate of probabilities came out very, very low. And also that one, the second part of that expressions question, which was the E and F, and then it was E minus F, I think. Yeah, that caught a lot of students out. Okay, I hope you found that useful. If you have, please do subscribe if you like. Any questions, comments, or feedback, feel free to type them into the chat. I'll get back to you fairly quickly. I'm fairly prompt with getting back in touch. Thank you for watching. I hope you found it useful, and I will see you soon.